Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you and your family in the best of health. Welcome back, dear students, in the second spell of final term. Dear students, this lecture is for grade 7, boys and girls, both wings, subject science. And in this lecture, we will start chapter number 7, that is about physical and chemical changes and processes. Dear students, this is my 19th lecture, and I am your lecturer, Mrs. Saira Jamal. Physical and chemical changes and processes. Changes in materials are going on around us all the time. You know that all the time in our surrounding we observe changes. Like leaves change their color, trees shed their leaves, milk changes into curd, iron nails rust into moisture, and some changes around us are slow and some are fast. In this chapter, we will study about changes in matter. You know that what is matter? All the things which occupy space and has mass are called matter. For example, metal has three states: solid, liquid, and gas, and a new phase is plasma phase or plasma state. Types of changes. There are two types of changes which we observe in our surrounding. Those two main types of changes are physical changes and chemical changes. What are physical changes? A physical change is one in which only the physical properties of a substance change and its chemical composition remains the same. Chemical composition means that the chemical formula or the chemicals from which that compound is formed, it remains same. Only the state of that substance changes. States I told you means from solid to liquid, or from liquid to gas, or even from gas into liquid or in solid. These are the physical changes, and their properties and their chemical composition remains the same. What are the physical changes? Size. You can see here the size of a fruit before cutting and after cutting, but the fruit remain same. Although the size of the fruit changes, but the composition of the fruit or orange, which contain important food nutrients like maltose, is present in citrus fruits like in oranges. So maltose will remain maltose. Nothing will happen to the maltose after cutting orange into slices. So size, shape, color are the physical properties of a substance which remain same. So burning of a candle, you can see, is a physical change in which only the wax changes from solid state into liquid state after melting. And cutting of a fruit into slices is another example of physical change. Physical changes are temporary and can easily be reversed, like when a candle melts into liquid state. After uh, blowing the candle, you will see that the liquid will turn back into the solid candle wax. Another example of physical change is freezing of water, cutting fruit into pieces, which I already told you, switching on the bulb, dissolving of something into another. For example, dissolving salt into water or sugar into water is a physical change which can easily be reversed. It is a temporary change and can easily be reversed. Can easily be reversed means that when we heat the solution of sugar in water or salt in water, after some time all the water will evaporates out, leaving behind the sugar or the salt at the bottom of the beaker, which shows that it was a temporary change, and that's why we get our reactant back. Ice melts or water freezes. Conversion of water into ice, and then the reverse of that process, ice converted back into water. It is also a physical change. It does not change the composition of water. The formula of water will remain same, and melting of ice or freezing of water is a physical change, because in this case only the physical state of the substance changes from liquid to solid or from solid to liquid, and its composition remains same. You can see conversion of a solid ice into liquid state and then liquid into the solid state. It is a reverse process and is a physical change. But in this case, water, if even it is in the solid state in the form of ice or in the liquid state in the form of water, in both cases or in both states, this is a water and it has two hydrogen atoms and one oxygen atom. This is a water molecule and it contains one oxygen atom and two hydrogen atoms. This is the composition of water. So if water changes from ice into liquid state or from solid into liquid state or from liquid to the solid state, in both cases the composition of water means the percentage or ratio of hydrogen and oxygen will remain constant. Nothing will happen to the formula of water. Extend your thinking, explain the presence of puddle of water on the sidewalk one day and its absence on the second day. Dear students, you know that after rainfall, puddles are formed, and when you see the puddle in next day, it disappears. How and why those puddles disappeared? So the process which dried up the puddles is evaporation. Evaporation is a key step in the water cycle, and in evaporation, when a liquid turns into a gas, it can be easily visualized when rain puddles disappear on a hot day or when wet clothes dry in the sun. In this example, the liquid water is not actually vanishing, actually it is evaporating into a gas, which are called water vapors. So dear students, at hot days, due to the sunlight, what happened? The water which are present in the puddles, they breaks away or they leave the puddles in the form of water vapors or in the form of gas. As the sun warms the water molecules go up into the air and the puddle begins to shrink, and then one time the puddle disappear. When all the water which was present in the puddle, it converted into the gaseous state or in the water vapors form. Chemical changes. A chemical change is one in which a new substance is formed. In the physical changes, I told you that only the shape, size, or color of a substance changes, but in a chemical change, not only the size, shape, color, but also some new substances are formed. They are changed and new substances are formed. These are permanent changes and are not easy to reverse. The physical changes I told you are temporary changes and can easily be reversed. But the chemical changes are permanent and they are not easy to reverse. We cannot convert them back into the original reactant. For example, burning of paper, rusting of iron, turning of milk into yogurt, cooking of food are some examples of chemical changes, and these changes cannot be reversed. Coal is carbon, and when we burn coal, it changes into smoke. It gives us energy, and it means that it also, the burning of coal is chemical change because the coal is converted into ash, smoke, and energy is released. So new products are formed. Coal is converted now into a new product that is ash. Along with ash, some other substances, some other products like smoke, which is definitely carbon dioxide gas and having water vapors. And then energy is released in the form of heat. And that heat we utilize to cook food or for the barbecue purposes and for running industries, because we also use coal as a fuel for running industries as well. So you can see here that the burning of paper, which turns into ash, it is an irreversible process. We cannot convert back the ash into original paper. So it is a chemical change. Then conversion of milk into yogurt is also irreversible change, and you cannot convert back the yogurt into milk. So it is also a chemical change. Another example is rusting of iron. You can see here the iron nails, and they are silver in color, but due to the rusting or after rusting, you can see the color changes from silver to brown color. These brown colors are actually the rust which stuck to the surface of iron. What is the reaction? Actually, iron nail react with the oxygen which is present in atmosphere and will form a product called iron oxide. Iron oxide, this 3 is actually the charge on iron or oxidation state on iron, which inshallah you will learn in higher classes. So iron oxide, formula of iron oxide is Fe2O3, which is also called ferric oxide. Ferric oxide or iron oxide is called rust. So that's why this iron oxide has brown color, so you can see the brown color iron oxide which stuck on the surface of iron nails. Iron react with oxygen of the atmosphere and will form iron oxide or ferric oxide, which is called rust. So rusting of iron is also a chemical process because you can see that these two compounds, these two elements, they react together and give a new compound. So that's why it is a chemical change. Burning of coal, I told you, is also a chemical process because after burning coal, it will convert it into carbon dioxide gas, give smoke, and also will convert it into ash and will give us energy. We utilize that energy which is in the form of heat for various purposes. Some clues to chemical changes, like how will you identify a reaction that either a chemical change takes place in that reaction or a physical change takes place in that reaction. So here are some clues to identify the changes in a chemical in a reaction. First one is formation of gas bubbles. If you see or if you find formation of gas bubbles in a reaction, it means that Actually, the bubble formation is due to the formation of a product which is a gas, and that gas, if it is a new product, so definitely that change will be chemical. Change of color during a chemical reaction and releasing and absorbing of energy. Energy release or absorption of energy, it is a chemical change. Formation of bubble takes place in a reaction, or some color changes takes place in a reaction, as I told you in case of the rusting of iron. The iron nails color changes from silver to brown, and that is also an identification of the chemical change. And formation of gas bubbles in the form of chemical reaction, when you mix two compounds together, and after mixing, if bubbles formation appears, it means that it is a chemical change, because a new product, a gas formed. And then releasing and absorbing energy. Definitely when energy is released, when you touch the glass and if it gets warm, it means that the chemical reaction takes place which absorb heat. And if the glass is warm, then it releases heat, and if the glass is cold, then the reaction or the reactant inside the glass absorb heat. If any one of the above clues takes place, it shows that the change is a chemical change. Extend your thinking. When we chew food, what type of change are we causing to the food? A physical change or a chemical change? Chewing food. The chewing of food is a physical change because the teeth grind the fruit into small pieces. This crushing and grinding is a physical phenomena or a physical change. But when the saliva mix with the food, saliva I told you in previous lectures, secreted by the salivary glands present in our mouth, when they mix with the food, so it triggers chemical reaction because enzymes and some chemicals are present in saliva which react with the food and moisten it and soft it. So that is definitely a chemical change. A physical change may involve a change in the size, shape, or state. State means solid, liquid, or a gas of a substance. However, its chemical composition stays the same. That this point I already told you in the physical changes. We have an activity 7.2 about the chemical change, that is rusting of iron. If we put a few nails in half-filled glass of water or in a test tube, and when you see after a few days, you will observe that the color of the nail and also of the water changes. From silver, it changes into brown color. It is called rusting of iron. The change of color from silver to brown is actually rusting of iron. And what type of change is this? Either it is uh, physical change or a chemical change. So you can see from this reaction that iron, which is present in water, and also oxygen, dissolved oxygen is present in water, also oxygen is present in the atmosphere in air. So the iron will react with oxygen and also with water and will give us a new product. That new product I told you is called iron oxide, ferric oxide. I told you the formula Fe2O3, and it is also called rust. And rusting of iron as a new product is formed, it is a chemical change. Activity 7.3, reaction of marble with bleach. So you are using bleach at homes for cleaning the like many you can say washrooms, and that is a good antiseptic or germicide. So pour some amount of bleach on a piece of marble, small pieces of marble. poured. You can see in this image also we have a flask in which marbles pieces are placed, and when we add dilute hydrochloric acid, which is also present in bleach, so what will you see? You will see that after pouring the bleach or hydrochloric acid on this in this flask, what will happen? Gas bubble formation will take place. You can see the gas bubbles, they pass through this tube and then are collected over water. Then these spheres actually show the bubble formation. So I told you the clue for the identification of a chemical reaction, that either it is a chemical change or a physical change. I told you the formation of bubbles. So you can see in this case that the bubble formation shows that this change is also a chemical change. So is it a physical change or a chemical change? It is a chemical change because the bubbles are actually the formation of chlorine gas. Means that bleach react with marble and will produce a new product. That new product is chlorine gas. And these bubbles which are formed or which are collected in water are actually the chlorine gas. So that is totally a new product. A new product is formed. So this change is a chemical change too. Then we have one more activity, that is observing a chemical change. For this activity, you need balloon, spoon, baking soda, vinegar, and narrow necked bottle. You can use water bottle. And procedure is that you have to pour some amount of baking soda into the balloon, and then add several spoonfuls of vinegar to a narrow necked bottle. In bottle you have to put vinegar, and in this balloon you have to put the baking soda. Then you have to stretch the neck of the balloon and you have to fix it on the bottle. You can see here, stretching the balloon and fix the balloon at the neck of the bottle. What will happen? The baking soda which you fill in the balloon will go down and will mix with the vinegar, will react with vinegar, and then what will happen? A gas will form, and then that gas will definitely, gases, you know that they are lighter in weight, they will move up, and then what will happen? Due to their movement, the balloon will deflate. The flattening of the balloon will take place. So this flattening of balloon, like the balloon will get bigger inside due to the filling of gas inside the balloon. That filling of gas inside the balloon show that a new product is formed when the baking soda react with the vinegar, and that new product form is actually a gas, and that gas is carbon dioxide gas. That carbon dioxide gas actually it fill the balloon, and the size of the balloon will become bigger. So you can see baking soda, which formula is NaHCO3, which is also called sodium hydrogen carbonate or sodium bicarbonate. It reacts with the vinegar. Formula of vinegar, you can write it in this form, H4C2O2, or also in the form of CH3COOH, acetic acid. It will give this the product, the main product, which is carbon dioxide gas, and that carbon dioxide gas actually it causes the balloon to get bigger in size. So it is a chemical change because totally a new product is formed. Then we have applications of chemical changes, where the chemical changes takes place, or what are the use of these chemical changes. As a result of chemical changes, new products are formed, and we are living in the world of chemical changes. What chemical changes takes place in our surrounding which are useful? So chemical changes are taking place in our bodies, in our vehicles, and in our environment. And the sometimes chemical changes form harmful substances too, like factories releases toxic gases, which react chemically with the rainwater and then make the rainwater acidic. And you know that acidic rain is very harmful, and it destroyed the forest, and also, as I told you, the acid react with the marble buildings and the metals and destroyed them. The oil industry uses chemical reaction such as purification of petroleum, which is a process like cracking of petroleum is actually the refining of petroleum process, and that is again a chemical process. The military uses chemical reaction in the gas bombs or in the bomb formation. Plastic making also involves chemical changes, which we know plastics are made up of monomers, and then monomer combine together to give us polymers. So plastic means a polythene bag or the plastic bags which we are using at home. They are actually polymers and they are plastic. Turning of fat into oil or oil into fat is also a chemical process. Then formation of soap in soap industry is a chemical change, because alkaline solution means bases or alkalis react with fats and then they give us soap. So all these were about the applications of chemical changes. Some chemical changes are beneficial for us and some are harmful for us. Then extend your thinking. Why do you think chopping of wood is a physical change, but burning of wood is a chemical change? Chopping of wood means cutting a wood into small pieces. It is a physical change, and the burning of wood is a chemical change. So, what do you think? Why chopping of wood or cutting of wood into small pieces is a physical change, and the other one like the burning of coal is a physical change? Chopping of wood, because in this case you can see that only the uh, size of the wood changes from bigger size into smaller size. Only the change is in the size of the wood. And I told you that changing in size of wood is a physical change. But the burning of wood is a chemical change, because when you burn wood, what happened actually due to the burning of wood, I told you new products are formed. Same like the coal, burning of wood will give or will produce ash, then smoke, and the uh, ash, smoke, and energy. It will release energy in the form of heat. And I told you that heat we use for various purposes, for cooking food, for as a heater for warming our cells, and for running engines, or for running industries. Various uses are over there, but the change is actually a chemical change because it turns into new products. Smoke is new thing, that is carbon dioxide gas along with unburned carbons, and then we have water vapors will form, carbon dioxide gas, and then heat, the energy released in the form of heat. So they are totally new products. From wood, new products are from ash, also a new product. So it's a chemical change. But in this case, no new product is formed. The composition is same. Wood will remain wood. If you cut it into small pieces, or if it remain in big pieces, it remain wood. Nothing will change except the size. So it's a physical change. So the burning of wood leads to the formation of new substances like ash, which is carbon, carbon dioxide gas, water vapor, heat, and also light. So this change is irreversible. We cannot convert the ash back into wood, and hence is a chemical change. While cutting wood into smaller pieces is a physical change, as there is no change in the original composition of wood. The composition of wood remains same. There will be no change in the original composition of the wood. So dear students, I hope you will understand this lecture. This was all about the physical and chemical changes. Also, we discussed some of the examples of the physical and chemical changes, and then the applications of chemical changes we are discussed. So inshallah, in next lecture, we will discuss the next topic. Till then, take care. Allah.